Good evening everyone. I am Sunita madam. Welcome to my class. Let us discuss types of oscillation in detail. Last class we studied about periodic and simple harmonic motion. In this class we will study about types of oscillation, resonance, everything in detail. Okay. In types of oscillation we have two types, damped oscillation and undamped oscillation. Oscillation are classified into two types, sinusoidal oscillations and non-sinusoidal oscillation. Sinusoidal, not sinusoidal. Sinusoidal classification oscillation are classified into two types, sinusoidal oscillation one type, non-sinusoidal oscillation another type. In this class we shall confine our attention only on the sinusoidal oscillation. A sinusoidal oscillation is the one which can produce an output having a sine wave form. Only sine wave form we will study the oscillation in this class. We have two types of oscillation. Already I told, damped oscillation and undamped oscillation. Here when you seeing the wave only you can confirm. In a damped oscillation, the amplitude of the wave, amplitude is nothing but height of the wave. This is the height of the wave. The amplitude of the wave, it will be decreasing as the time increases. Otherwise at increase in time you can see the amplitude of the wave, it will start decreasing. But in the case of an undamped oscillation, the amplitude it will be remain constant throughout the wave formation. Otherwise when the time increases, the amplitude of the wave it will be remain constant. That is the important one you have to remember. Okay, then that is the important difference between the damped and also undamped oscillation. In damped oscillation, the amplitude of the wave it will be decreases as the time increases. But in undamped oscillation, the amplitude it will be remain constant as the time increases also. Let us discuss in detail about the damped oscillation. The type of oscillation whose amplitude decreases with time is known as a damped oscillation. Already I told, the amplitude of a wave it will be decreases with time, that is known as a damped oscillation. Therefore, the damped oscillation is the oscillation which reduces in magnitude with time. The magnitude of the wave, it will be get reduced with time. The decrease in the amplitude of the damped oscillation is mainly due to the energy loss. You can ask, why ma'am? The amplitude of an oscillation in the case of a damped oscillation, it will be decreases. Why it will be decreases means there will be a decrease in the energy loss. Energy loss it will occur in the electrical system in which the oscillation are produced. Once the energy decreases, it will imply the decrease in the amplitude. The graphical representation, already we saw that one in the last figure. I will show once again here. See here. This is the graphical representation of a damped oscillation. As the time increases, the amplitude of the oscillation it will be decreases. Why it will be decreases? There will be a decrease in the loss of energy, otherwise loss of energy. That also you can consider. Next, a damped oscillation will fade away with time, otherwise decrease, fade away, everything it will be same. Damped oscillation may be further classified into three main types, that is underdamped oscillation, critically underdamped oscillation, critically damped oscillation, overdamped oscillation. The common example of damped oscillation are swinging pendulum. Yes, swinging pendulum is the important one. Then RLC circuit, weight on a spring. These are the few example of a damped oscillation. Even in the last class I told swinging pendulum, beginning it will be periodic, then after some time it will loses its periodicity. Why it will be loses its periodicity means because of the decrease in the energy it will loses its periodicity. Then in the case of an undamped oscillation, always you have to remember in the case of a damped oscillation, the amplitude of the wave it will be decreases. Why it will be decreases? Decrease in the energy of the system you can consider, decrease in the energy of the motion you can consider, anything. Okay, what is undamped oscillation? When the amplitude of an oscillation remains unchanged, amplitude it will be remains unchanged, you can consider, even constant you can consider, anything. Okay, it is called as an undamped oscillation. Undamped oscillation are produced by compensating the losses occurring in the electrical system in which the oscillation are generating. The typical waveform of an undamped oscillation, yes, we showed there. What will happen in the case of an undamped oscillation? Here also energy will lose, but that energy loss immediately it will be compensating, immediately it will be generated. Even though in undamped oscillation energy it will be lost, but simultaneously it will gain the energy also. There will be, that's why there will be no loss of energy in the case of a undamped oscillation. Okay, energy it will be compensating. Undamped oscillation are produced by compensating the loss occurring in the electrical system in which the oscillation are generated. That how much energy it will be lost, immediately it will be compensate, immediately it will balance. Okay, therefore undamped oscillation have a constant magnitude. Yes, you can consider undamped oscillation, it has the constant magnitude, do not die out with the time. The oscillators which are used generate undamped oscillations are called self-excited oscillations. Yes, a common example of undamped oscillation is alternating current wave. Alternating current wave. These are the best example of an undamped oscillation. Okay. What you have to remember in the case of an undamped oscillation, the amplitude it will be remain constant with time. Why this amplitude it will be constant means whatever the loss occur, whatever the loss of energy it will occur, immediately it will get balanced in the system. Okay, that one you have to remember. Then let us discuss in detail about damped and also undamped oscillation, even difference example, then how the energy loss, everything let us discuss in detail. Definition: an oscillation whose magnitude decreases with time is known as a damped oscillation. Already we discussed in the case of a damped oscillation, the amplitude it will be decreases with time. The type of oscillation whose magnitude remains unchanged, even constant we can consider, this is an undamped oscillation. That one we know. Then what is the change in amplitude? Amplitude of damped oscillation it will be variable, but here in the case of an undamped it will be constant amplitude. The energy loss, let us discuss the difference in the energy loss in terms of energy loss. The energy of the damped oscillation lost with the time. Yes, energy it will be lost. Two losses inherent in the electrical system used for producing the oscillation. Yes, energy it will be lost. How the energy it will be lost? Due to losses inherent in the electrical system used for producing the oscillation. In the case of an undamped oscillation, there is no energy loss or a provision to compensate the energy loss in the system. There is no energy loss. Energy it will not at all get lost. Energy it will not at all lose here. that energy immediately it will get compensate. Even though if it is loss also, immediately it will get replaced, otherwise compensate. Then life of oscillation. In the case of a damped oscillation will die out eventually. Yes, in the case of a damped oscillation, that oscillation they will get die out eventually. Okay, even they may die. In the case of an undamped oscillation, will not die out with time, oscillate indefinitely. Yes, it will be continuously, it will be oscillating. Oscillating, it will not at all die. The oscillation, it will not at all die. The oscillation, it will be indefinitely. Indefinitely means undamped oscillation will not die out with time. Oscillate indefinitely means continuously it will be oscillating. Then constant parameter, which are the constant parameter here. In case of damped oscillation, the frequency of the oscillation remains unchanged. Yes, frequency it will be remains unchanged as it is a function of circuit parameters. In the case of a damped oscillation, the frequency of the oscillation remains unchanged, means frequency it will be constant. Okay, in the case of an undamped oscillation, the amplitude of the oscillation it will be remains constant. In case of a damped, frequency is constant, but in the case of an undamped oscillation, amplitude it will be constant. Next, which are the types? In damped oscillation can be classified into three types. One is under damped oscillation, critically damped oscillation, over damped oscillation. Then here undamped oscillation, there is no further classification of undamped oscillation. Here classification we can't further classify on the basis of based on the variation in the oscillation. Yes, only in a damped oscillation we can classify. In undamped oscillation we can't classify. Example of a damped oscillations are swinging pendulum, guitar vibration, RLC circuit, weight on a spring. These are the best example of a damped oscillation. Next one, the common example of an undamped oscillations are alternating current or voltage, alternating current or voltage of a wave, swinging pendulum in vacuum. This is swinging pendulum in air, but here example of an undamped oscillation, swinging pendulum in vacuum. This one you have to mention, swinging pendulum in vacuum. This one is very important. That one you have to remember. These are the few major difference between the damped and undamped oscillation. Yes, once again I will revise it fast. In amplitude in a damped, it will be not constant, it will be variable, but in undamped amplitude it will be constant. Energy loss, in the case of a damped oscillation, energy loss it will be there. In the case of an undamped, no energy loss. Then life of oscillation, this oscillation, damped oscillation, it will die, but this undamped oscillation it will not at all die, it will be indefinitely it will be oscillating. Then here constant parameters, in the case of damped oscillation, frequency is constant. In the case of undamped, amplitude is constant. Here in the case of damped oscillation, we can classify it into three types: underdamped, critically damped, overdamped. But in the case of an undamped, we can't classify. Here the example of damped oscillations are swinging pendulum, guitar string, yes, RLC circuit, weight on a spring. In the case of an undamped oscillation, alternating current and voltage, swinging pendulum in vacuum. This one is very important. Okay. These are the types of oscillations we discussed. Damped and undamped oscillation. This one definitely they will ask in the exam. Then they will tell the difference between that one also. Then move to the next one. I will explain resonance in detail. Okay. little introduction for resonance here. Resonance, 1 minute, I will open the PDF. Yes, okay. What is a resonance? 10 to 15 minutes I will explain this one, resonance. Then after this class I will take one more class to explain okay. We will solve in the next class, we will solve few MCQ question based on the topic resonance. Okay, those are there in the live, tell me hi. Someone is there? Okay. What is resonance? Here this is the tuning fork. When you hit the tuning fork to a hard metal, then you can observe this, it will start vibrating. If someone is there, tell me hi. Who is there in the live? Yes. What is resonance? What is resonance? Object, mechanical system and uncharged particles tend to vibrate at a specific frequency. What does mean by a resonance? Resonance is nothing but object or mechanical system, anything, are charged particles. Objects are mechanical system are charged particles, here not changed, sorry. Charged particles tend to vibrate at a specific frequency. We can call this frequency as the resonant frequency or the natural frequency. Resonance, okay. When you any object or any mechanical system, any charged particles, then they will start vibrating at a specific frequency. Here consider a tuning fork. When you hit this tuning fork against the metal, it will start vibrating. Here this one is tuning fork. When you hit the metal, it will start vibrating. This is an example of a resonance. Here you can consider anything, any object, it will start vibrating. Any mechanical system, any charged particles, it will tend to vibrate with a specific frequency, with a constant frequency. That term, that process we will consider as a resonance. Okay, you will call this frequency as the resonance frequency or natural frequency. At what particular frequency it will start vibrating, no, that frequency we consider as a resonance frequency. When a light or a sound wave strikes an object that is already vibrating at some particular frequency, if that frequency happens to match the resonant frequency of the object it's hitting, then you will get what called resonance. Okay. When a light or sound, light also one of the form of it will be travel in the form of a wave. Even light also it will travel in the form of a wave. Then when a light or sound wave strikes an object that is already vibrating, if the object is already vibrating, then if anything light or sound, when it will strike an object that is already vibrating at some particular frequency, when vibration is there means that object it will be vibrate with a particular frequency. That one you have to remember. And if that frequency happens to match the resonant frequency of the object hitting, then you will get what's called as a resonance. If the already the object is vibrating, then if you bring another object, when you hit that object, when it will start okay, I will consider this example, I will explain here. See, this is the vibrating air column, this is the air column. This one it will produce a sound waves. Then sound waves it will vibrating with a some frequency. Then here consider a tuning fork. Take the tuning fork, then this system is producing a sound wave with particular frequency. Then when you hit the tuning fork against this any object, then this tuning fork it will start vibrating with the same frequency as the sound wave frequency. Both the frequency of the both the vibrating system it will be same. That process we will consider as a resonance. Resonance occur when the matching of vibration of another object increases the amplitude of an object oscillations. Okay, how the resonance it will happen. Once again I will explain what is mean by a resonance. Resonance is nothing but matching of frequency of the any two vibrating object. Here consider this box. It will producing a sound waves. Here you can observe here this box, it will produce a sound waves continuously. Then consider the tuning fork. This tuning fork, when you hit against any metal, it will also start vibrating. Here the sound waves, they will be vibrating with some frequency. Then this tuning fork, it will start vibrating with some frequency. When both the frequency of the object it will be same, then that process we will consider as a resonance. Resonance occurs when the matching of vibration of another object by increasing the amplitude. How you can match the vibration, how you can match the frequency of any two object, how you can achieve that one? Only when you increase the amplitude of an oscillating object. You have to increase the amplitude. This one you have to remember. How you can resonance any two object? Resonance is nothing but you are making the two object to vibrate with the same frequency. Remember this topic is very important. Resonance, when your mind, when you listen the word resonance, means if you can any two vibrating of object, if they are vibrating, then frequency of that vibrating object it will be same. Okay, how you can achieve that one? You can achieve by increasing the amplitude of an oscillating object oscillation. Okay, that is nothing but resonance. That one you have to remember. Then resonance in physics. How can we define resonance in physics? A phenomenon in which an external force or a vibrating system force another system around it to vibrate with greater amplitude at a specific frequency. Yes. Specific frequency you can consider, constant frequency you can consider, anything you can consider. A phenomenon in which an external force or a vibrating system, anything. If the object is already it is vibrating, otherwise you are bringing an external force to vibrate an object. Okay, a phenomenon in which an external force or a vibrating system forces another system around it to vibrate with greater amplitude at a specific frequency of operation. You are making another object, otherwise you are making another system to vibrate with the same frequency or specific frequency. How you can achieve that one? You can achieve that one with the increasing amplitude, with the greater amplitude. Okay, that one you have to remember. Then what is the, let us study the example of an resonance, then you will come to know. 1 minute, take a minute, I will open the window. Because outside noise it will be there, that's why I close the window. Now outside noise it will be there, that's why I close the window. But now okay, no one is there outside. Okay, then okay, we will see resonance. Understood everyone? What happened here? Sorry, something happened here. Okay, some technical issue. Okay, leave. Can you hear now? It will be okay. I pressed something. Okay, leave. It will be okay now. Next one, resonance example, musical instrument. Whenever a person hit or strikes, strums and drums or tweakers of any musical instrument, the instrument is set to into oscillation or vibration at the natural frequency of vibration of the instrument. Any musical instrument you take, first they will make an adjustment. Why they will make the adjustment? Because they have to set the frequency of a particular string. Everything when they will play, all the vibration it will be happen with the same frequency. A unique standing wave pattern defines each frequency of vibration as a specific instrument. Yes, for instrument to instrument, the specific frequency it will be vary. Maybe guitar it will be different, drums it will be different, everything it will be based on a particular frequency. These natural frequencies of a musical instrument are known widely as the harmonics of the specific instrument. That one we will consider as a harmonics. Harmonic is nothing but a specific frequency. Sorry for the disturbance. Some little changes I made, that's why. Okay, leave. Then suppose a second interconnected object or instrument vibrate or oscillate at that time specified frequency. Specified frequency means always consider constant frequency. In that case, the first object can be forced to vibrate at a frequency higher than its natural harmonic frequency. If the two objects they are vibrating with a same frequency, you have to force another object, it has to vibrate with the natural harmonic frequency. This phenomenon is known as a resonance. Already I explained. You consider this definition, otherwise you consider what earlier I explained, both are same. One object vibrating or oscillating at the natural frequency of the another object forces the other object to vibrate at a frequency higher than its natural frequency. Yes, both the frequencies it has to match. Okay, then only we will consider that is resonance. Here one of the example of a resonance is swing. The swing move forward and backward when pushed. If a series of regular pushes are given to the swing, its motion can be built. The person pushing the swing has to synchronize with the swinging time, which result in the swing motion having increased amplitude to reach higher. Once the swing reaches its natural oscillation frequency, a gentle push help maintain its amplitude. Yes, here you can observe this one. When the children when they are playing in the park, the parents they will adjust some frequency. Okay, they will push the swing to adjust some resonance or frequency. They will push 4 or 5 times, then they will leave. They will not at all touch, they will leave. Then that swing it will be continuously it will be oscillating because it requires some frequency. Okay, a gentle push help to maintain amplitude. Sometimes if they observe it started stopping, then they will push, they will give the only the gentle push. But if the push gives its irregular swing will hardly vibrate, this out of synchronized motion will never lead to resonance and the swing will not to go higher. Sometime what will happen when they will apply a force, sometime they will give more force, sometime they will give less force. In that case you are not able to maintain a proper resonance, because you have to apply a continuous force to maintain a particular resonance. Okay, next one, bridge. Next, consider the next example. Group of soldiers marching on the bridge are often asked to break their steps because their rhythmic marching can set extreme vibration at the bridge natural frequency. The bridge can break apart if the synchronized footstep resonate with the natural frequency of the bridge. Here consider a bridge is there. Here the soldiers, so many soldiers, they will be marching on the bridge. How they will march? They will march on the bridge with a regular synchronized, otherwise regular rhythmic marching. They will march with the rhythmic. They will put their pressure on the bridge with a rhythmic way. When they are doing like that, there will be a chance of breaking this bridge, because they are putting the force on the bridge. Rhythmically they are putting the force on the bridge, therefore naturally it may break. One of the example of the above is Taco, Tacoma Bridge collapse, where the frequency of the air matched with the frequency of the bridge, which they led to its destruction. Okay, here listen here. Here best example, this even in naturally also it occurred in Tacoma Bridge. I don't know where it is situated. I don't know. This exactly what I am explaining. This exactly it happened in Tacoma Bridge. Why it will collapse means the resonance of the frequency of the bridge, it will be matched with the frequency of the air. Here outside around surround this one, we are having the air. Correct? No. The frequency of the air is matched with the frequency of the soldiers. They are making the force, other they are making the rhythmic marching. Both the frequency, when it is matched, then that bridge it will get collapse, it will get destroyed. Okay, when it will get destroyed, the frequency of the air it will be equal to frequency of the bridge. What will happen? These soldiers, they are putting the force on the bridge. The force, it will start vibrating. When it will start vibrating, definitely it will get collapsed. Next one I will tell few important formulas. Then after that, if possible, I will solve MCQ question based on this two classes what I am explained, periodic motion and also resonance and even types of oscillation. Everything I will solve the MCQ question in the next class. How to calculate resonance frequency? Resonance frequency is the natural frequency where a medium vibrate at the higher amplitude. Yes, don't forget this one. To achieve the resonance, we need higher amplitude. Resonant frequency is usually denoted by F naught. Denoted by F naught. Resonance is witnessed in object in equilibrium with acting forces, could keep vibrating for a long time under perfect condition. Okay, this is the equation we will use to find the resonance frequency of a single continuous wave. We will use this formula. V, it will be equal to f lambda, where V is the wave velocity, lambda is the distance of the wavelength, F is the frequency. That one you have to remember. Yes, it will help when you will calculate the resonant frequency. Okay, remember the formula. Then different types of resonance, when the two are there. Okay, three are there. Okay, leave. After three I will stop the class. Okay, this one over. Different types of resonance. There are many types of resonance. They are mechanical resonance. Mechanical resonance can be defined as the tendency of a mechanical system to respond at greater amplitude when the frequency of its oscillation matches the system natural vibration. Always in your mind you have to remember resonance. Resonance means matching of the frequency. When the frequency of its oscillation matches the system natural frequency of vibration. Some system naturally they will be started vibrating. Its resonance frequency or resonant frequency. Okay, that it does at other frequencies. The resonant frequency of a spring is calculated using this formula. F naught, it will be equal to 1 by 2 pi into k divided by m. It will be in the inside the square root of k divided by m. M is the mass of the spring, K is the spring constant. This formula also very important. I will solve MCQ question based on the formula. Okay, the resonant frequency of a spring, this one. Last one what I mentioned, that one, to find the resonance frequency of a single continuous wave. This one is very important. Which formula, when to use the formula, that is also important. This formula also we will use to find out the resonant frequency, but this is applicable only for single continuous wave. Then this one, the resonant frequency of a spring. This is for a spring. Therefore, here you have to consider mass of the spring. Then you have to consider the spring constant. This they will mention in the problem. Then F naught, it will be equal to 1 by 2 pi into square root of K divided by M. Then acoustic resonance. Acoustic resonance is a phenomenon in which acoustic system amplifies sound waves. Acoustic resonance, it will be mainly based on the sound waves whose frequency matches one of its own natural frequency of vibration. Yes, sometimes the frequency they will get matched with their own natural frequency. Acoustic resonance is an important consideration of instrument filters, as most acoustic instrument as the length of the tube in flute. Yes, normally where we will use the frequency in musical instrument, when they will build the flute, they have to match the resonance. Okay, then length of the flute also, it will be based on the resonance of a particular instrument. Then string, flute, the length of the tube in a flute, the strings, and body of a violin, even body of a violin, everything it will be based on the resonance only. Even the strings we can observe in the guitar, the shape of the drum membrane use resonators. Acoustic resonance is also important for hearing. Even acoustic resonance, that also it will be important for a hearing. You can observe in the musical concert, so many, even they will use flute, strings, then violin, then drum. Even some singers, they will be sing, all they will be synchronized, then only you can hear a good sound, otherwise good voice, otherwise good song you will listen. Why you will listen the good one? Because the frequency of all this one, it will be like a proper resonance. In Kannada we will call shruti. Some they will those they are singers, normally they will tell your shruti is very good. Now means you are maintaining a proper frequency. If your tone, your frequency, your vocal voice, vocal that what it is producing a sound, shruti, everything it will be like synchronized, it will be resonance, then only you can hear the good sound, otherwise good voice. Okay, here to adjust that one, use, even though they are going the musical concert, they will adjust everything, whatever they are having the instrument, they will tune. Why they will tune? Because they have to adjust the frequency of a particular instrument. Okay, understood? That is nothing but acoustic resonance. Next one, electrical resonance. In a circuit, when the inductive reactance and capacitive reactance are equal in magnitude, electrical resonance occur. The resonant frequency in an LC circuit is given by the formula W. It will be 1 by square root of LC. W, it will be nothing but 2 pi F. F is the frequency of the resonance. L is the inductance. Remember that one. L is the, C is the capacitance. Electrical resonance, name itself it is indicating electrically, otherwise the resonance we can achieve in the electrical. Okay, in a circuit, when the inductive reactance and capacitive reactance are equal in magnitude, when they are in the same value, electrical resonance occur. Inductive reactance and also capacitive reactance, both they will be, both the values it will be in the proper resonance, then that one we will call it as a electrical resonance. This one I will explain once I will explain the modern physics in detail. I will explain what is meant by inductive reactance, capacitive reactance. If I started explaining, it will take more time. Oh, but we will use the formula. That's why I included here this one. Then the resonant frequency in LC circuit is given by the formula W. It will be 1 divided by square root of LC. Remember the formula. I will explain in detail this one, electrical resonance. Okay. Then W, it will be 2 pi F. F is the frequency. Then L is the inductance. C is the capacitance. That one you have to remember. Okay. Now, at least now I finished everything. In the last class today I took 2 class. I don't know, nowadays no one is coming to the live now. That's why I am making recording. I am sending because from last 2 days I was busy in some other work. Today I am free. That's why whenever I will free, I will make a video. Then I will send you. At least those who are free, see the recorded video, watch the recorded video. If you have the doubt, you can ask me. Last class in detail I explained periodic and simple harmonic motion, everything. Then now I explain types of oscillation, resonance, everything, which are the formulas we will use, everything. Maybe today only I will take one more class, that is MCQ based on this topics, oscillation and wave. Okay, this I need 3-4 classes. Still this topic is not completed, but how much I will be completing theory part, that much I will include the MCQ question, then easily you can understand. But this one is easy topic, oscillation and wave is easy topic. You can see the recorded class also. If you watch also, easily you can follow. Okay, thanks for everyone watching my class. Please share my videos to your friend, those who are preparing for CTET, TET, hstr. At least they can make use of the classes. Okay, thanks for watching my class. Thanks everyone. Take care. Bye bye. Read well. Okay. Okay, bye.